For this section, let's continue and talk about methods and the beginning of some coding techniques. Methods are a difficult topic, and they're only difficult because that's the heart and soul of computing, right? Is figuring out the solution to the problem, figuring out the algorithm, figuring out the chain of logic. That's an intrinsically hard problem, and you're going to do that in the methods. So methods are something that it takes a lot of practice to get good at. I can give you some techniques and tips on what I believe works well and processes that believe that work well. But remember, this isn't something that you're going to have a hard time with in CS 225. Even professionals sometimes have a hard time answering the question, do we need a method for this? And if so, which object should contain it? Okay, so remember, classes are composed of attributes and methods. Attributes describe the state, and methods modify or report the attribute values. This is key. All methods have access to all attributes in the object, and that's the biggest reason for making something an attribute and not a variable. You want to put something in main and make it a local variable in main, fine, but nobody else will get to use it, so you can't do any method calls on it. So you want to have those things to be attributes, and then all the methods can use those values. Think of them as the idea of a global variable, but they're global only in the context of the object. In order to declare a method, you have to state its visibility, is it static or not, its return type, its name, and input parameters. So, visibility, public or private or protected. Almost all your methods should be public. You have to come up with a good reason to make them private. Sometimes you have a method that helps the other methods in your object, and nobody outside the object might need to see it. For the general purpose, though, your method should be public. I'll hit on this later on in the talk, but I'll say it here too. If you think about your object as a service provider, and you ask, what services should this thing provide to external entities? Think about it. What can you do with a toaster? Oh, it provides a service, right? It toasts things. It also provides a service where you can dial up and down how long you want the thing to be toasted for, right? These are services that are provided to the external world. So think of your object as a service provider, and then say, okay, for every service I need a method. And because it's a service to the outside world, it should be a public method. Then you determine if your method should be static or not. And the answer is it's not. Unless it's main, public static, void main, string args, it's not. I sometimes see students who are frustrated, they can't get their methods to work, and they make it static and it works, and what they have not done, they have not solved the problem. They have put a band-aid over that problem and probably created another one. Static methods, the only one should be main. Now you may have multiple mains, right? You can have mains in different objects, that's fine. Each one of those can be static, but other than that, do not make them static. Then you specify the return type. Typically this is going to be an int, but it could also be an array, or it could be an object. So you specify the return type. If there is no return statement, then use void. Then you name it and put in the input parameters. And so here's an example. Public, everybody can use it. Void, it doesn't return any values. Its name is foo, which by the way is a common computer science name for a nonsense function. And its input list is integer x, integer y. Notice these are comma separated declarations here. And then after that you would do curly bracket, body of the method, curly bracket. The method's signature is its name and input parameter list. So if you ever hear that term, the signature of the method, that's what they're talking about. So here's an example. Since I find it difficult to justify creating a static method other than main, right? Don't do it. That means that you can't use the method until you create an object of that class. Again, I'll see students doing this too. They try to reference a method and they get an error that says null. You tried to access a null, and the reason is they tried to access a method but they never created the object first. Create the object first. How do you know you created the object? The new keyword. So here I've done a silly class, as most of the examples are. Public class method example, and it's got attributes X, Y, and Z. And inside of main, the first thing I do is I actually create an object of this class. Method example, object or obj equals new method example. Obj is my generic name that I use for objects in examples. If I have more than one, it's obj1 or obj2, whatever. So method example obj equals new method example. Now I've created an object of this class and I can use the method. So I say obj initialize attributes, that's the method. There's the method down here. That's the method. Notice I had to do it this way, obj dot. I have to say the name of the object and then the method. What I'm saying is, look, there's a method called obj, and its class is its type is method example, and inside that class there's something called initialize attributes. Same thing here, obj.x. I have to actually name the object, and the reason is I could create obj1, obj2, obj3, and I have to specify which one I want to talk to. So here I just created one, but if inside the main here I have to do obj.x equals 0. And I only bring that up because look what I do down here. Once I run initialize attributes, every method has access to the attributes of that class. I don't have to do obj.x, obj.y. In fact, I couldn't. It wouldn't work if you think it through. I already told the computer which specific object I want to deal with. I want to deal with object obj. So it already knows it's obj.x, obj.y, obj.z. And if I wanted to do an obj2 and an obj3 and an obj4, as soon as I say obj3.x, this x is known to refer to, obj3 initialize attributes, then that x would be already associated with obj3. So that's a slight thing that can hang people up. When you're making the methods, and you remember the methods have access to all the attributes, when you're making the methods you just need the attribute name. But whenever you're outside the method and you're referring to the method or referring to the attributes, you have to say, I want that attribute for that specific object. It's a slight distinction. So whenever, and usually you do it from an external class like this. So from the external class, okay, so I've got this random data class over here, and it's got some methods, initialize data, and whoops, I got someone messed up here. Initialize data, print data, and calculate maximum. So the first thing I do is I make an object of that class. None of these are static methods, nor should they be, so I can't use them until I create an object of that class. So I create an object of the class. Random data, my data equals new random data. Now I say my data, see the name of it is my data. My data, initialize data. So I'm saying that specific object, run that method. And I put the value 14 in here because, let's go back to the array discussion for a minute. I declared an array inside of random data, but I did not make the array. Why? Because I don't know how big it is yet. So I wait until someone tells me the size. And so I let initialize data take in as its input parameter the size of the array that I want to make, and then I actually make the data here. I make the array here. Data equals new, int, now I know how big it is. This is a common cheap trick. And then just to initialize the data, I did this standard, fill it up with dummy data, fill it up with random data, using the for loop as before. So this is how your code tends to look. I think of random data, and again, think of random data as a service provider, and I ask myself, what methods does random data need? All right, so one of the services it should do is initialize the data, initialize itself. One of the services might be to print the data. One of the services might be to find the maximum element, one might be to calculate the average, one might be to find the minimum. Right? You think about, here's this object, what will people ask it to do? What will other objects ask it to do? And each one of those becomes a method. So by not, I've lost my thread. So that's how I knew what the methods would be in the random data. And these are the examples that I'll use in class, by the way, too, so we'll talk more about them. But then all I have to do is create an object of that class and then call the methods. Notice, if you do this where you don't do work in main, my advice is inside of main, don't do any work. Just call methods. Then it becomes very readable, it becomes very legible. And inside of other methods, if you find that you're writing a lot of code, you might want to break that down into smaller methods too, because this is pretty straightforward. Oh, let's see, we created a new random data object, and then we initialized it, and then we printed it out, and it looks like we're going to find the maximum and find the minimum. By naming your method names well, then your code becomes very clear. If anyone needs to know the details of how that was done, they can go over here and look at the methods. Notice they're quite short. That's normal. Now, in addition to these methods here, I would have all this. I would have normally have setters and getters. In this case, I don't really have any need for a setter and a getter for the data. The initialized data basically sets the data. Okay, so when do you make them? You think through the design process. You make the attributes needed to describe the state. So you're designing your project. Okay, I need a class for this. I think I need a class for that. What attributes do I need for each class? You know, think of the sheep-sheepdog game. We went through and said, okay, for a sheep, I need X position, Y position, X speed, Y speed, max speed. Right? These are the things that describe the object. And then don't make attributes for anything that's a temporary variable. You can take care of that later. Don't make attributes for anything that can be calculated. Like in the previous one, I didn't make an attribute for the max value or the min value. Why? Because I have a method that can calculate it. And if I ever need it, I can calculate it. If you store it in an attribute and then you change the data, you also have to change the attribute. You might forget to do that. So anything that can be calculated, don't make an attribute. Okay, so then you say, hey, okay, I know all my attributes. Then you start thinking about how will this object be used? What do I need it to do? What questions will someone ask of this object? If you think of it as a service provider, what services are needed? Now, other objects can ask the objects to do those tasks. So you want to make setters and getters for every attribute. You want to make public methods for the tasks. Let's say you decide that your object is going to do task A, B, and C. You make public methods for task A, B, and C. And then if those public methods for task A, B, and C are complicated, you might want to break them down and have some little helper methods. Maybe those are private, but maybe not. So if you're writing a method for task A and it's 100 lines of code, my recommendation is don't do that. Task A is clearly not one task, but several. So break it out into its several smaller tasks and make smaller methods. Each method should do one specific thing. That's why they're so small. When do you make them? Well, let's see. You go through and make the attributes needed to describe the state. This is the process, right? Go through the attributes, describe the object state. Think of how somebody's going to use the object that you're creating. I already did this, right? Oh, no, I didn't do this. And then do, it is the same slide. And then the only thing I'll add to this then is, yes, this can be difficult. This can be a tough problem. And then how do you do it? Here's my process. I create my user stories. This is what we're going to talk about next week. Basically, I describe the functionality that I want my program to have. Then I create the software design, not the code, the software design. And the way I do that is I say, okay, in order to do this job, I need an object to do this, an object to do this, an object to do this. So I'm identifying all of my classes. Then I say, what are the attributes I need for each class? And then I say, what methods do I need? I do not solve them yet. I do not code them. I don't even know how something might be done. I just know that it has to be done. And then I'll create all of my classes at once with their attributes and with their methods, but the methods are all empty. They're do-nothings. I'll figure that out later. Why would I do that? Well, now I've got working code. I've got all of my code working. It doesn't do anything, but it works. And then I go through my user stories. Remember the idea of the sprints where you pick 2 or 3 or 4 user stories and say, in 2 weeks I'm going to get these done. I've got working code, functional code to begin with. And then in this first sprint, I'm going to say, okay, at the end of this sprint, I'm going to have user story number 1 and number 2 done. Well, in order to do that and test them, I probably need to build out half my code anyway, but I'm not ready for that yet. So I'm just building it out with these empty methods. The whole code works, but all I get are print messages and dummy values and things like that. And then I can run my software and test it. So when I'm working on a user story, I'm working on one small specific part of my code or a couple of small specific methods, and I can actually test them to see if they work. And then go on to the next user story, and then go to the next user story, and go to the next user story. And I'm going to keep doing that until all my user stories are done and I have all the functionality that I told myself I would have. So describing the program functionality, that's going to be your P2 deliverable. Then designing your classes, again, you are not solving the algorithmic code here. You are just saying these are the classes I need and these are the jobs they need to do. You don't need to know how they're doing them yet. That's your P3, that's your design. Then as part of P4, I'm asking you in P4, which is your first sprint, to actually complete a couple of user stories, but I'm also asking you to have all of your classes with all of their attributes and all of their methods, even though the only methods that actually do real work are the ones that satisfy your user stories. That's part of P4. And then the rest of your code drops P4, P5, P6, P7. All you're doing is working on the methods that are needed for that specific user story at any point in time. That's my process. It more or less follows the agile process. And so it makes writing your code manageable. Will you go back and change your design? Sure, sometimes you will. That's okay. But unless you have this basic skeletal code, as we call it, or a walking skeleton, unless you have that skeletal code, you can't really test your code to see if it's working anyway. So you build it all out first in a dummy form or a skeletal form. It functions. It doesn't do what it's supposed to yet, but it functions. And then you go back and fill in the functionality and flesh it out. Okay, we'll talk about this over on Fridays primarily, but I'll also show you examples in class.